Hello everyone. We are going to be covering section 10-3, day 2. You're going to need to have your note packet out and a pencil and calculator ready to go. For these beginning bullet points, these are just a summary of what we covered on Friday. So, two central angles are congruent if and only if their corresponding or intercepted arcs are also congruent. Two central angles are congruent if and only if their corresponding intercepted chords are congruent. And finally, two minor arcs are congruent if and only if their corresponding intercepted chords are congruent. We covered all of that in day 1 of section 10.3. We're going to do a few more things with chords and arcs in circles today. This first theorem says, in the same circle or in congruent circles, if two chords are congruent, then they are equidistant from the center. So, what we're saying here is segment FG is congruent to segment JH, and those are chords. So FG is congruent to JH. If that's true, then that would mean that this distance is the same. So we are going to say that our conclusion is LX is congruent to LY. And we can apply that in a couple examples. This says, in circle E, GE is congruent to FE. We are being told that the chords are equidistant from that congruent statement. We're also told that segment CD is 3x minus 4. I'll go ahead and label that best I can. RS is equal to 14. That is a typo, my apologies. That should say AB. So we're going to say AB is equal to 14. And GE is equal to x minus 2. What is the value of x? What is the length of GE? Well, the first thing we want to do is conclude that these chords are congruent to each other. We're applying this property up here, but in reverse. So our equation is going to be 3x minus 4 equals 14. Start solving for x by adding 4 to both sides. I have 3x equals 18, and when you divide by 3 on both sides, x is equal to 6. So I could go ahead and plug that into my answer spot. Now to find GE, you need to take 6 and plug it in for that expression. So that will be 6 minus 2, which is 4. The length of GE is 4. In our next example, it says in circle Z, RQ is congruent to SR, so the segments themselves. So let's find those. RQ is congruent to SR. Okay, so we have two chords that are congruent. We need to write a congruent statement for the arcs, write a congruent statement for the radii, and then calculate x. So, from yesterday's theorems, we know that this arc and this arc are going to be the same measure because those arcs are intercepted with congruent chords. So we're going to say that arc SR is congruent to arc RQ. For the radii, we've got them here and here. So we're just going to say segment ZY is congruent to segment ZW. And finally, we need to solve for x. We are going to apply today's theorem, which says the chords are congruent. So they are equidistant from the center, which means that this segment and this segment must be the same size as each other. So let's go ahead and set up that equation. We're going to say 5x is equal to 3x plus 4. I'm subtracting 3x from both sides to get 2x equals 4. And then when you divide by 2, you get x is equal to 2. Okay. For our next theorems, we are told what we can conclude about a segment if it is bisecting perpendicularly a chord. This says if the diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Because this segment right here is a diameter and it is bisecting, or it is meeting perpendicularly the chord CD, we know it is bisecting the chord. Okay. So we're going to say segment AB is perpendicular to segment CD. Because they are meeting perpendicularly, that would mean that it is cut in half. So we can say segment CE is congruent to segment ED. It did say that it also bisects its arc, so if you would like, you can say arc CB is congruent to arc BD. This is kind of like an inverse, but not quite. This says the perpendicular bisector of a chord is a diameter or radius of the circle. So here we see that segment SQ is perpendicular to TP and it's bisecting segment TR. That is enough for us to conclude that TQ must be a diameter. So we're going to say segment SQ is the perpendicular bisector to TR, and that helps us conclude that segment SQ is a diameter. All right, we're going to do just a couple examples with these, and then we'll be done with notes. Here it says in circle O, segment AB is a diameter, so we know that to be a fact. It says that CD is equal to 44 inches, CP is equal to 7x plus 1. What is the value of x? The first thing I want to point out is that CP is only this portion, and it's 7x plus 1. CD, on the other hand, is the whole thing. CD is 44. Well, we know that because AB is a diameter and it's meeting perpendicularly at meeting perpendicularly through CD, then it is a bisector. So these two things are congruent. So all we have to do is take 44, cut it in half, and set it equal to that other half. So I'm going to say 22 is equal to 7x plus 1. And start solving for x. 21 is equal to 7x, divide by 7. 3 is equal to x, and we're good there. All right, we've just got one last question, and it says, in circle C, point D is the midpoint of segment AB, and CH is a radius. Mark in the image any perpendicular or congruent segments that you are able to conclude. Because D is at the midpoint, we know that those are going to be, either half is going to be congruent. Also, because CH is a radius, and up here it says the perpendicular bisector of a chord is a diameter or radius. The only way for this to be going from the center while bisecting is if it is a perpendicular bisector. And we are done with that. I hope this has been helpful. You can use these notes and yesterday's notes to help you finish 10-3 quizzes, and I look forward to seeing you guys in class soon.